Starting
Live.
Okay.
Right.
Well, hello everybody. This is our third Hangout On Air. We're very delighted to have with us Dan Garcia from UC Berkeley, and he will be sharing many different things with us. There's a few housekeeping things I'd like to mention. Several of you have asked about what it means on the pre-survey to have a score of 36. All that means is the way we did the surveys, we have assessments. We have to record them as assessments, and that's actually some kind of score, but it means nothing to us. The survey has no right or wrong answer. Forward, so the assessment score to have a 36, and then some good news. If you haven't seen yet, it's been posted out what the rise in the AP Computer Science A exam has been. There was a 33% increase in the CSA exam, so that's exciting news. And then the new hours code announcement just came out, so there'll be some things you can see about the hours code for this coming December. So again, we're very delighted to have Dan Garcia with us. Many know Dan from all of his work in computer science education. Dan is an ACM Distinguished Member for all of the great pioneering work that he's done. And we'll have Dan for the next hour or so, and we will have a chance for you all to ask Dan some questions through the Piazza site. And I think Dan's going to kick it off with a demo of Snap. So we have a lot of Snap things coming up, and we thought it would be most appropriate for Dan to kick that off. And then if you'll watch over the next evening, we'll have a lesson that has probably 6 or 7 different videos. So lots coming out on Snap over the next 24 hours. So we'll kick it off and let Dan show us some things with Snap and talk a little bit about the beauty and joy of computing. So Dan, can you take over for us?
Sure. Thanks so much. Hope everybody can hear me okay. Welcome. I'm so happy you're all here. You virtually. I see nobody in the audience except Jeff, but I'm doing pretty well. Jeff will represent the audience for me. And I'm really happy to be here. So I'm going to talk about Beauty and Joy of Computing, our BJC course, and mostly Snap, because you're going to be using Snap for your programming for this PD. So let me do a screen share. I'm going to see if this worked earlier, see if this is going to work here. And start screen share. Let me know if you've got a picture of Snap. How are we doing on that, Jeff? All right.
That's good.
Okay, great. Perfect. So this is Snap. It was built off of Scratch. I actually have a slide that talks about some of that here. Let me quickly get to that one. We built Snap because we loved, let me just do a quick screen here. So we loved the idea that Scratch had a graphical way to work. It was just wonderful. And also loved that it was really easy for beginners. So it was a really nice language. It had blocks. You had over here you had a sprite, a set of sprites down here. You can drag in your own custom picture for your sprite. So it's really nice. The difference between Snap and Scratch, people always ask us, is that Snap is in the browser. In the early days, Scratch was not. So Scratch and Snap grew out of BYOB, which is build your own blocks. The idea with Scratch is that you couldn't, early versions of Scratch, you couldn't make these things. These are blocks you drag out, and they have an effect on the world. So here, this is a move 10 steps block. Here's my sprite. And when I do this, you can possibly see this little guy's moving to the right. And you can do things and compose them. I can click them, and when I do this, it snaps in. There's a sound button. If I say a clicking sound, as I do this, it goes click, and it does that. And so when I run this, this thing is now turning and moving. So this is a kind of a motion block. This is a do it block. They call it commands, the ones that are shaped like cookie cutters. Then there are operator blocks that return values. So I always argue that your simplest program should be something really short and in a very interpreted way. So you look at Java's first program, and it's 30 lines or 15 lines, and the students have no idea. This is the student's first program. They click the button, and it's join. Join is a program that kind of concatenates 2 words together, and here's their first program, join hello world. That's pretty cool. This didn't do anything because it didn't say anything. And this has the ability to say things just like Scratch. So I can go to looks, and I can say, and I can say join hello world. Notice I'm now composing this. This is now going as the input to that. When I release it, it snaps in, and now when I say this, now this guy says hello world. So it's a really beautiful, very functional model. If you want to live in the functional space, functional languages allow you to have only one return value, then you have none of these blocks that look like cookie cutters, and you can do all your work by composing things. You know, you can have, here's a mod, and that might, this value, you know, let's say 3 mod 2, that's 1, that might go over here, and now it's 1 world, and I can now add here, so I can, this is a way in Snap we've added to be able to have multiple arguments, variadic functions. These arrows allow me to change that, so I could change this guy to be a space. Here's a little representation of a space, and here's a world, and I say now this is 1 world, okay? And you have to say it in a very deep way when you do these things. So that, you can use this in a functional way. You can also use this in an imperative way. So you have people do things like move, turn, turn. If you've done the hour of code activities, you see some of that where you have to make, excuse me, you have to make an Angry Bird traverse a maze. So you can have people do this. I wanted to show you 2 of the coolest things in this program. I wanted to show you how to make a game. I want to show you how to make a game in 2 minutes. So I'm borrowing this from the folks at App Inventor, who have created a really, really outstanding dynamic way to create a game in their tutorials. So I want to do this together, and by doing this, I'm going to show you how to do this. So I'm going to start by going over here, and I'm going to start by finding a picture. So the way it is you find your hard drive, and you go find, I have a set of pictures here. Here's my BJC folder. Here's my new default logo. We have a new beautiful logo. Here's Alonzo 3D. I just drag it over here. Think, actually, upside down, but it still works. He's rotated because I rotated my cursor. So I can now say to this, go back to the scripts window. This is scripts here. I can say point in direction 90. Now he's there. And I can also say in my looks window, make it a little bit smaller. So this is my, I'm going to set this up and set size to maybe 10% here. Okay. So there, maybe 30%, 20%. That's a little bit bigger. Okay. So there's my default logo. His name is Alonzo. He's gender neutral. He or she, we call Alonzo, but it could be a she. This is just a generic picture. This is Gobo from the Scratch media library. So I just dragged in some media. The wonderful thing is I can just drag anything in. So I can have sounds. I can have an MP3 file. Just drag it in, and I can have a sound get played automatically. I can also have XML files. This thing saves itself as XML. I can have it. I'll show you that a little bit later. And so I'm going to make a game. So ready? Let's start a timer. Let's see if I can do this. Ready? 109. Go. I have to maybe 112. I'm going to do this. Okay? Ready? So first, I want to have him move to a random spot. So here's go to X. Whoops. I have to go into scripts window. Go into XY. This is going to move him to a random spot. How do I get randomness? Well, pick random number. 1 to 10. 5, 3, 9. I happen to know that the size of the screen is from about minus 240. We'll do a minus 230 just to give it some room on the edges. From minus 230 to 230. That's the X value. Okay? That goes in X. Bink! And I can now right-click and say duplicate. That's the same thing. I'm going to change it. The Y value is 1. It goes from 180 to 180, so I make it minus 170 because the range is minus 180 to positive 180. Okay, so here we go. Still playing my game in 2 minutes. Ready? Go to X. And now, as this gets clicked, this guy's going to a random spot. Look at this. Bam, bam. I'm halfway done. I'm literally halfway done. Okay? Control. Control tells you how to do control flow. So I'm going to go over here to forever. Here's my forever block. Forever, go to a new spot, and wait a second. Ready? Go. Look at that. He's now running around to a random spot. Okay? 110 still, so we got 2 minutes. Here we go. So now I want to have something to do is when I am clicked. So this guy responds to events by these hat blocks. So when the space key is pressed, when I am clicked. When I am clicked, I want to do what? Well, let's make a variable. Make a variable, let's call it score. I always use this is a global variable available to all sprites and all scripts. This is my score. When I'm clicked, and by the way, when I do is I have when this is clicked, you often start these programs with the green flag. Up here is the green flag. So when this is clicked, I want to do what? Well, let's probably reset our score. So set score to 0. There. Now it resets it. And when I'm clicked, I'm going to say change score by 1. Look at this. Bink. Now I also like to do this. I also want him to move to another spot. So I'm going to duplicate just this, put it here, and now this is my program. I believe I'm actually done. But I think I want to put this above there. There. Now I have a beautiful program. When it's clicked, when I start the program, set score to 0. And then forever, go to a random spot and wait a second. If I'm clicked, change score by 1, and you'll see the score. I can now run this by clicking this button. This is now the full screen version. There's my score in the upper left. I could say go, green flag, score. Uh-oh, got him. Whoops, missed him. Now, before I do this, I want to fix this. One of the things I need to fix is this thing is draggable. Draggable means I can grab it around. So when I clicked it, it thought I was trying to grab it. Now I'm going to say it's not draggable. It'll do this a little better now. So now I'm going to full screen, run it, ready, score. Come on. Well, I got one. That's two. That's three. Big. There's four. Hey, I got it. Pretty good game. Now I can easily add a sound. I don't think I have a sound with me, but let me see how fast I can find a sound. Do I have a cat sound? Meow, meow, meow sound. Meow that wave. Look at this thing. I grabbed this guy here. Where is that meow that wave? Okay. Oh, got it. It's now opening my iTunes. Let me go find it here. Meow.wave. Show meow.wave. Meow. All right. Whoops, 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 whoops. Those here. Meow. Show all in Finder. Meow's over here. Let me get my meow.wave guy. Images, sounds, cat meow, meow.iff, meow.wave. Let me see how that works. Okay, play this. Okay, I don't know if you heard that, but I heard it. Okay, so here is my meow.wave sound. Now watch this. Sounds, bink, make the window smaller. Bink, drag, meow.wave over here. Bink, play it. It just went meow. I'm not sure if you could hear that, but I heard it. It said meow. And now, watch this. Go back to scripts. One I'm clicked. Sound. Play. 113. Oh, it took me another minute to get the sound. Play sound. Play sound. Actually, you want to do the following. You want to say play and continue. Sorry, play sound. That's the asynchronous. There's two versions, play sound and play sound until done. These all come from scratch. This says play it, but don't continue the script until you finish the song. This says play it instantly, and even if it takes a long time to play it, it kind of is in the background. So there's the sound in the background. Okay? So here we go. Let's try it again. And ready. And maybe let me turn my let me quit my mail so I stop getting these annoying things. And back here and go. Reset. Hey meow. Hey meow. Look at that. Done. Huh? 114. That was about 2 minutes. It took me about a minute and a half to get the sound. I'm done. That is incredible. This is really great. It is so much fun authoring this stuff. Here you've got events. Here you've got loops, control flow. You can change global variables. Really, really nice. So what I do is I think I'm logged in. If I'm not, I'm gonna have to log in, and you do that by logging into the cloud. So I think well, let me try to do this without doing the cloud first. So this is a cool thing. So I'm gonna go over here and close this window here and give myself a little breathing room from some space. Okay, close that. I don't know what that one was. Oh, there's my terminal window. Okay, so watch. I can say export project. Yoink. This is XML. I say save as. This is now, I'm going to say desktop and say it's whack-a-mole. Whack.xml. Done. I've got an XML file that stores everything. Okay? You say, what do you mean stores everything? Well, let me go over here and make a new snap. By the way, you go to snap by saying snap.berkeley.edu/run. If you just go berkeley.edu, it'll bring up a web page, which is nice, and if you scroll down, you can say run snap now. And this is now snap. So, this is a brand clean window, right? I click this, here's my whack.snap, over here, done. I just drag it over. So, it's kind of neat that you can use your desktop in the way to use media, sounds, costumes, and files themselves. There is also a way to save this to a cloud. Once you save it to the cloud, you get a URL. You can share this with anybody. I can take a URL and pass that around to friends. So I actually have a version of this that I've done before, and I believe it's called, I put it on tinyurl.com/BJCTopia. I did this for the Topia conference. Let's see if that works. And that's now going to load up Snap and load this program. See how fast it takes to, oh, look at this. Look at this. Loading up Topia. And this is the very, very, very polished version of the same thing. So we basically added a background, have a max score, have it, if it's kind of cool, it also speeds up as you, I'll show what it looks like. Here's the code. Snap sometimes doesn't refresh. There we go. So here's the code. It has more blocks. It has a delay. The delay gets smaller as you continue the game. I can say go. Keep clicking me if you can. And let's see what's wrong here. Let's say click. Okay, something happened to go a little wonky here with the blank guy. I don't know what happened with the blank. It worked a second ago. I can try to reload this. Bet you it'll work. I think something about closing it and opening it was a little weird with the browser. There, that looks fine. Click this and then go. And now he switches direction every time I get him. And every time I miss him, he draws a line to the next spot. So it kind of draws this picture, and he gets faster at clicking. So this is the same idea that I did in 2 minutes, but we've kind of added more pieces. And we did this for the hour of code, where you had students walk through the 10 steps for that. So now it's going pretty fast after doing this. And every time it misses, it goes down by 1. So it's kind of a nice little game. Phew! I want to show one more feature. I know that we were supposed to end at 1:15. Let me just show you one more project that I think is really, 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 really cool. This is Jens's codification. You can get to this. I'm going to close all these extra snap guys just so I have a little faster. Okay. I have some interesting kind of, here we go. Now let's go to here, and I'm going to say tiny URL. You can, by the way, follow the same URL I'm doing. BJC codification. Okay, BJC codification, no spaces, no capitalization necessary. This is a demo of the power. Some students always say, oh, this is a block-based language. When are we going to learn a real programming language? And we tell them, you've been learning computer science all along. Just because you happen to have used a blocks language doesn't mean it's any less powerful. This is a Turing-complete language. You say, what do you mean? We say, well, anything that can simulate a Turing machine is equally powerful. So what we do with this particular project is we have a way to map every block to a text equivalent in a particular language you care about. So what's really cool is here's a very simple program. This is called the FizzBuzz program. This is often used for interview questions where and students play this. This is a drinking water game where you go around a circle and everybody says a number, increases. You continue to increase your number above the one. You add one more number to the one that was just said. So 1, 2, 3, 4, 5. However, if your number is divisible by 3, you say fizz instead of the number. If your number is divisible by 5, you say buzz instead of the number. If it's divisible by 5 and 3, which is 15, then you say fizzbuzz. Okay. So I can hide the code, and I can now just run this. And here, 1, 2, fizz, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, fizz, buzz. Okay? Easy. I'm just running this program. So you say, that's nice, Dan, but your point was to show me the power of this compared to other languages. So I say, sure. Set script to this. Blocks are data, by the way. One of the things that's powerful in this course that we teach and in Snap is that you can have recursion. You can have functions defined using themselves, and functions can be data. So this whole block can be the input to this block. Set script to that. Now that's the script. Now I'm going to go to the bottom and say, watch this, set script to this. Okay, watch the bottom. Go to the bottom. Here we go. I'm going to say map to, oh, I don't know, Python. Watch this. Map to Python. This is now, all it does is it goes through the block that was the script, and it says code of script, which is, for each one of the lines, translated to Python. So now I'm going to say export this, and this, my friends, I'll zoom this in, is Python. I didn't write this. This was written automatically by converting it to Python, just one-to-one mapping all of the control structures and assignments to Python. I now say copy, here's my handy-dandy window, Python, enter, paste, enter, enter. My friends, there is FizzBuzz in Python. Ooh, you all collectively say. Then I say, aha, how about map to C? You say, wait, that was only hard-coded to Python. No, we have mappings to many languages. In this particular project, you can map to 1 million languages. This is an open framework. It's just a project, nothing special about it. So, map to C. It looks like C to me. Export. Make this guy bigger. It looks like C. All. Copy. Let's try it. Okay, here we go. Get out of Python. Cat greater than fizz.c. Paste. Enter. GCC minus O. Fizz.c. Fizz, ladies and gentlemen, in C. Wow. Okay. Pretty cool, you say. Well, how about map to JavaScript? No, not JavaScript. Oh, certainly, yes. Here's JavaScript. Export. You're kind of getting the point. This should be an export. Did that guy not? This guy hang? Let's see. That was my C window. That was my Python window. Here we go. There's my JavaScript window. All copy. Now I have to go remember how to do this. Window. I think it's View Developer JavaScript Console. Down here. Can I make this guy bigger? Bigger. Paste. Enter. And I don't know if you can see it. I have to drag it up. But ladies and gentlemen, FizzBuzz in JavaScript. So that's a little teeny demo for showing you that this we always bring up because folks, i.e. my students, this is a wonderful language. If you learn computer science in a blocks language, you're learning no less than if you learn it in a text language. And in fact, you're learning more because of the ease of being able to make interactive programs. You ask a C programmer, hey, I want you to make a program where make my whack-a-mole. Ready? Go. They don't have the opportunity. They have to load in 75 libraries, and a month later they've got a whack-a-mole. Ask anybody in Python, and yeah, you can try to import some libraries, but you're not going to have the ease in 2 minutes to create whack-a-mole. So you get all the power of a text language. Again, this is Turing complete, all the power of any language, but the ease of getting in is really a huge win for learning to program. So we use this in our course, Beauty and Joy of Computing, as I was mentioning earlier. Here's how we teach recursion. This is a picture of recursion. Let me see if I can show you here. Do this. I have another screen going, but maybe if I did it. How to teach recursion? V. And so here's the thing. V. Oh, I should probably just show you V. Let me just show you. This is cool. Jeff, watch, let me check in. Let me do a check-in. Let me check in now with Jeff and let me know. Should we jump on questions or should I show them recursion?
There's one question. Some of the teachers are asking where they can get FizzBuzz and where are some of the URLs that you could.
Sure. So the first one, the FizzBuzz, was, that's a great question to ask. I believe it's tinyurl.com. Can I type it into the?
Yeah, if you can type it in the chat, I'll transfer it to Piazza.
Perfect. Okay, so let me make sure this guy works before. tinyurl.com/BJC codification. Now let me copy and paste that myself before I send out this crazy thing. And is it loading? Yes. Okay, so that's it. Let me hit enter now. So that's the first one. Yoink. The second one is tiny. This is just URL shorteners. tinyurl.com/BJC Tapia is the second one. And let me try to find the V. I think we had BJCV in here. Let me see. I'm pretty sure we saved that at some point. tinyurl.com BJCV. Do we have that one? Let me see. BJCV. Give me some love. I forget where we stored this one before. Remember? Hey, we got BJCV. Okay, so I'll put that over here. All right, let me get here. Okay, tinyurl.com BJCV. Okay, so let me show you the V demo. Okay, so this is one of my favorite examples of teaching recursion. And by the way, one of the reasons we teach recursion is we want people in our CS Principles course to be prepared if they'd like to go into the AP with enough computer science that they don't really just struggle after that. It's really kind of a bait and switch if you don't have enough programming so that they think they got it with the AP Principles and then they don't get it. So we have a little bit more meat. Recursion isn't in the AP Principles, CS Principles course, but we add it because we love it and we think it really does highlight some of the beauty and joy. Again, our course is called the Beauty and Joy of Computing. We think some of the work that you get with recursion is really beautiful and joyful in terms of the fractals that you can draw. So here's the star likes the hex. Here's how this works. This is a very simple program. This is called vSentence. And I happen to have modified this to be able to make a connection that we're able to generate arbitrarily long English sentences as well. Here's the star likes the hex. Now, how does this work? So let's go over here and show you, I'm going to show you one of the lists. So these are ends. This is a list. I'll go over here. Whoops. Let me clear that off. I didn't want to show that one yet. Clear that, clear the screen, and go there. Okay, so I figured this. So here is a list of ends. The hex, the star, the square. Okay. What this program does is, this is called vSentence. It wakes up, turns left, draws a line, and then picks one of these shapes to draw, the hex, the star, the square. Zoop. Backs up, turns another 90 degrees, goes out and does it again. Picks one of these randomly. Let me show you what that code looks like. Okay, and it's a little more complicated than the purest V because I have the sentence thing here. But let me just see if I can find this for you here. V sentence. So, okay, I want you to ignore some of the words about the set sentence stuff because I had to get this a little more complicated to that. So, here we go. Script variable about turn left 45 degrees, move length. Okay, ignore this orange guy. Move, set sentence to call item any of ends. That says go to the ends list, which is over here. You saw that, the hex, the star. Pick any of them. Just randomly pick one of those three and then call it, meaning do it. Now the pen was down. We have a pen model like logo. You have a pen you can drop, you can raise, you can move around. So this is just a modification to make a picture here. So I set sentence to be left parentheses, the left guy. And then, this is a little bit of Englishy stuff. Forget that little thing. I made it more complicated. Then turn right, move length, do it again. Okay? There's a joining verb, which is this guy likes, who likes, just to make the English look right. Then move back and turn 45 and do this, report sentence. Okay? So that got a little complicated with the sentencey stuff. But the idea is, this is going to, when I click the red button, or click the screen, I think even, it'll randomly choose one of these guys on the left and randomly choose one of these guys on the right. The star, and make a sentence out of it. The star likes the hex. Click again. The star likes the star. The star likes the star. Okay? The square likes the hex, randomly. So this could be any one of three things. This could be any one of three things. And now here's the beautiful thing. Ready? Watch this. This is the magic of recursion, and I need to give credit to this demo to Paul Goldenberg, who wrote this V demo, one of the best ever. And I think using it in Snap, he used to use it in Logo, and I think using it in Snap makes it so visual, so wonderful. I'm going to hit up arrow. And what have I added? I've added V sentence itself to the list. So V sentence is the guy that wakes up and gets run. Look, V sentence is when I receive V, which is broadcast V, start this guy, set the length to 50, go to this place, clear, pen down, point up, say V sentence. Means it calls V sentence, has a side effect, and then says the output. So it says what that is. Okay? And pen up, and then go to this corner so that it kind of gets out of the way. So V sentence is the guy that drew the left, right with the ends. But what does it mean if V sentence is part of the thing that V sentence can choose? Might this go on forever? He puts his finger on his chin like Austin Powers. Here we go. Ready? Let's try it. What do you think will happen, team? And you ask the students, and they all have a conversation. This is where active learning happens. The students all talk to each other and do this. Let's try it. Ready? Ooh. It happened to pick hex and hex, so it didn't pick V sentence either left or right. So that's pretty cool. Oh, and look at this. I love this one. It happened to pick square 3 times. That's so interesting. But look what it made. It actually made a valid English sentence, and on the left guy, it picked V sentence. So it has its own left and right guy here. And it happened to pick square, square, and this happened to pick square. But look at the sentence. This actually reads like a sentence. It's kind of like a depth of traversal here. It is the square who likes the square. Which square likes? Okay, somebody over here likes this square. Okay, somebody left likes this square. Who likes this square? Oh, it's this square who likes that square also likes that square. Too bad that they're all three the same. But that's a really nice example of, this is an infinite sentence. This is a sentence that's just generated automatically, and this can be infinitely long. Let's try it again. Ooh. Okay, so it's the star who likes the star who likes the hex who likes the hex likes the star. So it's this star liking that star, but which star is it? This guy who happens to like this guy, who happens to like this guy, who happens to like this guy. Now, you say that's kind of cute, but what happens is you get one of these big ones, which we'll keep doing this until I get a big one, and the class literally says, oh. And when that happens, that's the first time that a program surprised them, which is really cool. So here, this is a kind of nice one, but it didn't really kind of fold the screen. The other problem, by the way, is with this saying it, is that it often blocks some of the beautiful, oh, here we go. there's something. So the point is, this is a program that surprises you, and every time may generate a different picture. It's kind of like a snowflake. It may generate a different picture every time, maybe. Or it may be all the same every time. Who knows? But this is showing you that, A, this is a beauty by showing randomness. It finesses the base case of recursion, because the base case is just when you didn't choose this guy. It's kind of cool. Students ask, can this run forever? Sure, it could. What's the probability it runs forever? 0. Even if you had 100 V sentences, the chance that this runs forever is 0. The chance that this keeps picking this thing is actually infinitely small. So anyway, the cool thing is it doesn't often run forever. Big picture, nice. And it shows kind of a intro to recursion. The students don't really understand recursion. This is the first time we show them that. And then eventually we show them how to draw fractals and pictures and all those things. But this is a kind of nice way to show that that there's some beauty and joy in not only the picture that's the output, but one of the things that's important to us is to show the beauty and joy in the code itself. V is actually beautiful in how simple it is to go left, pick the thing from the ends, go right, and when it itself becomes part of the ends, there's actually beauty in that elegance. So that's my demo I wanted to show. I wanted to do one more thing, which is to show some of the output. So this is a picture of here is the percentage of women in our non-majors course. This is the wiggly line up here is the picture of 2 different courses we had, and it wiggles between 30% and 40% women. This lower number, wiggling between 12 and 25, is our majors. This is 20 years of longitudinal data, 1993 to 2013. And for the first time in history, we broke 50% women attending our course. So we've never at UC Berkeley in the history of recorded history, 93, and they believe it was much worse before that. No, we've never had an intro computer science course have 50% women. And this course that year, spring of 2013, eclipsed that mark. And again, in spring of 2014, we're higher than that. We have 52% women, and they typically do better than the men in terms of their GPA. And this is a picture of some of the women who were successful in our course and continue to join our course on the staff. So I just want to share some of the things, and I think a big attribute to the success we've had in terms of engaging everybody and broadening participation, which is one of the goals of APCS principles, is reaching this audience who previously wasn't being reached. And I think a big factor goes into graphical languages. And this is honestly pretty. You know, it's kind of fun with these things. There is a point where you get really good at coding, where the time to make a program, where you can type as fast as you can think. See, when students are first learning, they can't type as fast as they can think. So they don't mind learning this, but at some point they begin to code faster. Oh, I know how to do this, and bam, I have 5 blocks I need to drag there. And the blocks actually slow them down. So that's why we have eventually actually added in our BJC curriculum, we call it Besides Blocks, which is a whole set of curriculum which transitions to Python seamlessly. So the idea is we start with this codification. You show how all their old code can, in theory, go to Python. And then what we do is have a couple of weeks in Python. So it's not Java, but we think that Python's a right next connection from our students. So we officially have Python as part of our curriculum. Let me go back and stop screen sharing and maybe stop that now, and now open up for questions and talk to some of the folks and talk to some of the people that have brought up some issues.
Yeah, so one question that I have, Dan, and we'll get to some of the teacher questions. The work that we're doing over the next week with Snap is somewhat limited. I don't have a lot of time. Do you have like some suggested resources where folks could go? I mean, are there other Snap MOOCs, or are there other tutorials or places where we can go to get more extended instruction after they even go through my MOOC here?
Sure. So let me point you to some of our curriculum that we have online, because the first couple of weeks is just Snap. So let me point you to this website here, bjcberkeley.edu, and if you click on this guy, and if you go to that link, I'll drive the screen share again and show my screen so everybody can see it. If you go to that place, then here's the BJC curriculum. I can zoom in now. And right in the center is Try Curriculum. And if you go there, the intro, we have all of our labs. Most of our course is online in that you can, and it's all online in a self-paced way. So you can just click on you know, here's build your own blocks, where you're learning to build your own blocks. We have people use Snap in a very Scratch way for the first couple of lectures, and then we've moved to build your own blocks, where you're actually making your own functions. Because the power is not just using the functions that come with it, but actually making your own functions. So that comes over here. Let me just show you over here. If I right-click this, make a block, and I can choose what I want it to be. And here's, I'm going to make the double block really quick. I can make it an operator. Here's a reporter. I can say OK, and here's a double block. And now I can say make an argument. I'm going to take two arguments, an X, and I'm also say plus, and make an input Y, and it's going to report X plus Y. Okay. Oh, actually, whoops. A double wouldn't have an X and a Y. I'm going to delete the double, just double one argument. So here's X times 2. Okay. Here's 2 times X. Okay. And I can change this. If I don't like X because X looks like times, I make it an N. And then I can now I can throw the X away and make it N. Now it looks a little cleaner. 2 times N. There's double N. Okay, ready? Okay. Now I've got a block that I just made. I added to the set. So these blocks on the left didn't come down from the mountaintop. You can actually add to that. And that's something that Scratch didn't have initially, and we were kind of the unique group to have a Scratch-compliant version that allowed you to make these blocks. And I want to give all the credit to Jens Monig, who was the developer of BYOB. So making your blocks is a really important piece. So if I go back to this curriculum, we kind of have 3 weeks of just getting used to Snap, just playing with it. Here's build your own blocks, where you learn to make your own blocks. And then here's our first thing of data structures. Remember, the only data structure we have is what Scratch has, which is a list. But our lists are more powerful than even today's Scratch, because our lists can hold other lists, and they can be made on the fly. So in Scratch, you have to say, make a list over here. Here, we can have a list that is just, here's a list of 2 things, 1 and another list. And here's a list of foo. So this is a list of 1 and the list containing foo as the first element. So you can make a list of lists right now on the fly and just have this really cleanly done and return lists. So we can return lists from functions. You can have lists as input to functions. You can change them within a function and not be global. And that's an important thing. So we have that. So anyway, we talk about that in our list section. Tic-tac-toe is kind of a mini project where you try to do tic-tac-toe to try to make use of that. One of the things, by the way, that we also think is really important in our course is the idea that because functions can be data, you can make use of idea of higher order functions. So let me go over here and say import tools. When you say import tools, it's going to give me a set of blocks that I'll just show you really quickly. One of the things that people do is common patterns, like, oh, I want to do something to every element in the list. And it usually takes people 5 lines of code to do that. Well, once you get and realize that that's a pattern, here's 1, 3, 120, I can now say, what if I wanted to double every element there? Well, you know, so you could write a Python thing, write a C program, but watch what happens here. I'm going to now have functions as data. Here's this list as the input to a map. I take a function, drag it into this gray. The gray border is a signal to you saying, I'm expecting a function. I drag an argument with an empty slot here. And one by one, each of these list items is going to be fed into this, and it's going to make a new list on the fly. So let's try this. Don't point in that direction. Go. Here, 2, 6, 240. So the point is, here's a mapping function, which is do this function to everything. Here's a keeping pattern, which says take a list and keep the elements that satisfy some case, like keep the odd ones or keep the students who have grades above A. That's a common pattern we do in life. Here's a combine function that smushes things together. I love this, an example that kind of basically says find any function that you might want to combine things with. Let's say plus, and now take this list 1, 3, 120, and combine of that is going to yield 1 plus 3 plus 1 plus 20, 124, and there's 124 because it adds them all up. I can also use this in a way that's actually quite clever. If I say join, this is a really nice thing that we've done before as demos. So this is, by the way, takes a 2-input function. So here's a 2-input function. That has a value, a comma. There's a 2 holes. So I drag this into here, and what do I get is 1, comma 3, oops, comma 100, comma 20. So it kind of smushes things together in a way that takes the first 2 and puts the first element in the 1 and the 3 here, then the result of that in the first with the 100. So it kind of eventually smushes it together in a kind of cascading way to do that. So combine. And the beautiful thing is these two blocks, map and combine, are what Google uses in the abstract way. Google uses to program their data centers. They use a map reduce, and this is map and reduce. So we're allowing our students to program and see some of the really powerful abstractions that are used in the professional level in this very simple, beautiful graphical way because of how easy it is to have functions be data. This is a lot easier than it is I could have a list of functions. It's a lot easier than it is to do in, say, Python or C. C is a function pointers. Python doesn't do it. So it's really nice to be able to have functions data as one of the big ideas. So let me now get off my thing. But anyway, the point is, here you'll see some of that here. So we use functions as data. We use some of that in the first 3 topics, and we actually teach you how to do that a little bit later. So let me go back to you and stop driving and then answer some more questions.
So Dan, the question came up about the ability to export your blocks so you can use them in other programs or even share them with other users. So what capability of Snap allows you to share your blocks?
Sure. So you can share your whole project. As I showed you how to export as an XML, that's a text file. You can email that to anybody, and that's fine. You can also log into Snap, and I didn't do that because I hadn't logged in before, but you can log in, save your data to the cloud, much as you do for Google Docs, and then once you've done that, you can send them the URL for where it is. So that's a really nice feature. And I was going to show you how to do that if I can remember my, let me see this one here. See if I remember my account. Hey, I'm connected. Good. So I'll just show you a quickie thing here. I'll do that for you. Maybe that's worthwhile just to show you for. It'll probably take a minute to show you that one. Let me do screen share again. Okay, so show that one. Start screen share. So now here's this. Let me make a new guy. Throw that away. Say new. I've shown you the 3 links to all those guys, right? vSentence, and the 2 here. Yes, replace with the new one. Here's my new function. Brand new. Clean. Okay, watch this guy. Ready? Control. When this is clicked, motion. Repeat forever. How fast I can do this? Let me see if I can do this here. Repeat forever, move 10 steps, and turn 15 degrees. Ready? Go. Very simple. Okay? Kind of boring. I might even pen down it just for fun. I might even put some pen down in here. Pen down, bink, and here we go. Ready? Go. Makes a circle forever. Okay? There actually is an interesting thing. It's kind of a fun thing. I do this one, which is I think as if on edge bounce. So watch, this is a fun one I often do. I've ever seen this one before. So move 1 step, and not just turn 15 degrees, but what if you turned a random number from -3 to 3? So, and now just to make this clean, I'm going to clear the thing. This is a fun game here. So clear it forever, do this, move 1 step. And now here's a key thing. I believe under motion there's if on edge bounce. And this basically says don't leave the screen. Okay? And just for fun, what we can do is we can actually change the color, change the pen color by 1. So now it's going to change by 1 every time it does this. And ready, full screen, and go. And it's kind of meandering its way around and kind of bounce. It just bounced off the screen. See that? It used the whole thing. All right? That's pretty cool. So I can do this. And by the way, I didn't show you this. There's a turbo mode. If I hold Shift and hold this, this goes in turbo mode, which draws this really kind of pretty picture. Okay? I like this. Simple. I did it in 1 minute. Okay, stop. Get out. Let me show you how to share this. So I'm going to first say save as, and you could save. I showed you how to save XML. I can also save to the browser. Every browser has a couple of megs of free space, and this is able to save on that browser and that space. So here's my browser. I have a brand new browser. I just installed this new OS, so I have nothing there. That's nice, and it's great. It's great on airplanes, right? If you have no Wi-Fi connectivity, you always have a browser cache that you can store to. The problem is, if I lose and reinstall the OS, or if I change machines, I don't have it, right? It was stored to that machine, and I can't get it out. I can't quickly see it on the file to drag it out. XML, I can save it, put it onto my flash drive or something, or USB drive, but I don't like that. I want to be able to save to the cloud. So a cloud is a way. I've logged in, by the way. If you go to the Apple, you could say sign in, or sign in initially, or make an account. I already have an account and I'm signed in. It remembers me. It'll say that there. So now I can say Jeff Hangout random. That's pretty cool. Random. Okay. So now I say save. Watch out. I say save. And now it's going to saving project to the cloud. You can say, see it here, maybe saved. Great. Now I'm going to say open this. There's a little bit of a thing to do. Once I've saved it, I have to now find my file again here. H2, 3 here. Jeff Hangout Random. Here, it even shows you the picture I had here. I can click the word share. It's going to say, are you sure you want to publish this? Yes, I am. And I have a big screen, so it's hard to read this one. But here I go. Then I say open. Now watch what happened. Not only is it published, but my URL changed to the shareable URL. I'm now going to take this and go into my favorite URL shortener, which happens to be the day. Oh, ShoutKey is, by the way, I want to give a props to that. ShoutKey is a really fast way to generate a URL for class. I do this all the time. So expires in 24 hours. Shout it. Palatial. So you say shoutkey.com/palatial. So let me copy and paste this guy here into the window, and you can share that with everybody to see if that works. Let's try that one. Paste. Bam. Now, just for fun, because ShoutKeys expire, so it's a great way. By the way, one of the great things about Snap is if all my students are following along with me, I can say, all right, folks, go to this page, ShoutKey, page Palatial, right? Okay, fine. And now here's the best part. I go and make a change. Okay, so everyone go, by the way, please everyone go load that in and have it on their own machine, including Jeff, everybody here on the team. Load this, shoutkey.com/palatial. Okay? I'm going to go in and make a change to this. And you're going to say, ooh, that's weird. Let me now make this, change the pen shade by 1. Okay, and do this one here. Change the pen shade and even make the pen size. I think the pen size, I'm going to set it to like 3, maybe 5. Okay, I'm making a new project. Okay, let's try this one. You can watch me if you want. And now a bigger guy, and he's a little brighter. Okay, notice he's a lot brighter and bigger. Okay, now watch. I now say save. Bink. Now, if you were to go to this ShoutKey, what would happen is you would get the updated version. So it's a great way in lab, if you're working with your students and you're evolving some code, what you can do, where's my, oops, there's my, I'm trying to find my original thing, there. You can keep making changes, the students can follow along, and then at any point you say save, and that URL that pointed to this project still is live. So Jeff Hangout Random is now the updated with thicker pen, brighter colors. So it's really very, very, in terms of best practices, if you're using Snap in the classroom, what you want to do is you want to do this shared model. Make a small URL. Here it is, shoutkey.com/palatial. Have every student go and relaunch that. If I were to go and click this, it's going to launch the new one with the brighter picture. Here, see, brighter picture rather than the old one. So it's really nice that your students can reload what you're working on as you're evolving during a tutorial. So I think I'll stop and take questions, but I wanted to show you a little bit of how to share using Snap in the cloud.
Let me jump in here for just a second. I wanted to tell everybody that while you were doing that, I went to the URL and I even added in some code. I added in the clear the drawing by hitting the space bar. So at some point they might have seen all the writing disappear. That was my ad right there.
Well, this is important that we talk about this. That's a great comment. Thank you for that. When students go to that URL, I did not, and Snap does not have the ability to have everybody add to it. Only I can save to that URL. So what you did was make a change to it. If you didn't save it, it's only on your local machine. If you did say save, it's going to ask you where do you want to save it, and it will not let you save it as my file. If you look at the actual URL that shows up, I think the URL shows up as something like username is Dan Garcia, project name is Jeff Hangout Random. So no one else has a right to has the ability to write to the Dan Garcia kind of folder, but Dan Garcia. So we should be clear that everybody is getting a copy of that, and they can make their own changes, but they won't mess with my original, which is, I think, the safe way to do things. We're thinking about modifying Snap to be able to have that feature. So I can say, share the URL with you in write also mode. So if you were to happen to write to it, like a Google Doc, you would make the last change, but then you have conflicts, and we haven't worked out the details of that. But that's what future plans for Snap is to allow that kind of collaborative work remotely, which is a great idea. So thank you for suggesting that.
Okay, great. So we had an earlier question also. Well, one of the very first questions that came on. So I can come back and find that. So it deals with the increase in the female students. So you indicated at BJCs for non-majors, is the hope that a percentage of the BJC students become EECS students, or are you just trying to educate in general everybody about computing for their
That's
own?
very good question. We have multiple goals. So many people are taking my course BJC who are seniors, and we're not going to convert these folks to computer science majors. They're leaving in a semester or so. But the hope is that we make an engaging enough experience, just like the CS Principles course in high school, that some fraction decide, wow, this is awesome. I need to major in this stuff. So it really is the case that the goal is twofold. To bring people in like the Pied Piper of old and make them excited about what we're doing so that they want to take the next course. That's certainly one of our goals. And that's even why we have the Python at the end, because our first course for majors is in Python. So we kind of have this impedance match where we try to set them up for the last couple of weeks to do the same thing that they're doing in the first couple of weeks of the next course. However, we also think that the CS Principles course we've built, and CS Principles in general, is a good enough course that if you were to take only one course in your life in computing, that's a pretty good course. I would say take that over the APA. I think that gives you more perspective of what you can do with computing, that computing is creative, that it has impact on society, more than just here's a coding course, go ahead. Not everyone's going to be a Java coder, but this does give people a nice intro to what you would do as programmers, and it gives them a really nice foundation in terms of being a gentle upslope of a learning curve with a graphical language. So it is both to bring more folks to the major, but also for those who aren't, we think it's a pretty good dynamite course. And all CS Principles courses have that perspective, which they're great courses for people as one-offs if they really aren't going to take anymore.
So Dan, I know that Snap can interact with robots and some other external devices. What do you plan about also, like if I want to bring the concept of data and do that within Snap, or what other things in CS Principles can we bring into the Snap context, as well as other things like devices and so on?
Oh, I love it. Thank you for this. You're almost a plant, Jeff. That was really great because I had forgotten to mention one of the cool features we've added to Snap, which is a particular block we use, and I'll try to let me go back and grab the screen again and show you this particular block here and start. And go back to here. I'll make this new and start here. Okay, replace it with the new one. This is a block that we affectionately call the HTTP block. And I believe it lives under sensing, I think is what it said. Here we go. This block is how all of the input and output works with Snap. It's really dynamic. So by the way, let me show one more thing. I can make a variable, call it foo. I always, by the way, use all my global variables, call them foo. When I say global, because we have local variables, this is a local variable. So I would have called this guy foo. And so this is something in line. If I just need a variable foo, and I want to set this local guy to foo, this is like, in Java you can make int I, for int I equals 0 to 10, blah, blah, blah. You can do the same thing here. Here's a local variable that only exists for that length of that script. Once it's done, foo goes away. So you can have multiple script foos in here without conflicting. There is one global foo here. We're inheriting that from scratch. If you set the global guy, set foo, to be a list, here's a list of 1, 2, 3. Ready? This is a line, another line, hello world. Okay? List of 3 elements. Bink, bink, here's foo. Watch this. This is how I get data out of Snap. Click. I can say, okay, so foo. Now, I'm going to say this. I'm going to say set bar. Watch this one. I'm going to make a foo. So make a variable called bar. And I'm going to set bar to be a non-list. Because it's an interesting thing. Watch this. Set bar to be. Now, how would I convert this to a list? To like a non-list thing? Well, there's something called, I think it is under my tools. Let me import tools just in case I need this guy. Bar is here, and if you watch, I go to bar, and I can say, let me see, I'm still waiting for tools to load. I can say import. I can also say, click here, one, import. Where's my export button? Oh, export. Okay. So set bar to 0, and now can I say what bar is? Import. Let me remember. Okay, import. So watch, this is a line, another line, hello world. Watch this. Let me go to a text editor here, and make a new document, and say, Jeff, let's see, Alabama, Dan, California, okay, Jan, Washington. Okay, I just made a simple text file that had this. Okay, I'm going to save this as, let's see, text, put this on desktop, text, people.text. Okay, here's bar. I say import on bar. I choose people. I say open. And bar now has data from the outside. So at the very basic way, you can say explicitly say import on a variable, and it loads into that. But I wanted that actually to be a list. Look, Jeff, Alabama, Dan, California, Jan, Washington. So what we have is, this is kind of cool, we have a split block that's able to split something by, and when I say split, means generate different elements of a list by different words. So watch this. This is split hello world by space, and there's hello and world, two different elements. What if I split bar, okay, by, and watch this, by carriage return. Bink, oh, sorry, by line, I'm sorry, line. Look at that, see? And I happen to have a spare guy here, an extra line on the bottom with the carriage return. So, but the point is, here's a way to get data in from the outside using import. Here's a way to get data into list form. And most of the time, once it's in list form, then you process on it, right? Then you can keep all of the items so that the teacher has higher blah, 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 blah. So the point is, this could be an input to something, right? I can say, here's this, and keep items such that, I'll just show you a quickie one here, such that the letter 1, the first letter starts with J. How about that? The first letter of each word starts with J. How do we do that one, right? So letter 1 of that thing equals, watch how easy this is, equals J. So in terms of filtering, one of the things you often do with data is you filter it, right? Here, this could be a 1,000 elements long. And letter 1 of blank, which means one by one, the elements of each line here are going to be fit into here, and I keep the elements in which the letter 1 is J. Ready? Bink, Jeff and Jan. With the thing, with the keep and the thing. Okay. So, long story short, we typically argue that snap could be used for the data task. You bring stuff in, which I just showed you here. You can do filtering, very simple filtering, like keep, like map, like combine, you smush it, filter it, do all these fun things. We even have, as I said here, we even have a data. This is the kind of fall 2013. We made a change to this and added some new things. And here's the most recent work. Go to this link. And if you click on this, this is the spring 2014 curriculum. You're going to say using data. So we actually had a whole module on using data with Snap. And so and it's a really nice little exercise. It talks about you're trying to trace a person and they've left GPS coordinates, and you do some fun things. It's really fun. So all that's using Snap. So the point is, that's a way to get data in. You can then, now I can say export. Once you have a variable that's set to something. So for example, let me make a new guy variable here, and let me make a new one called out. Out. Okay, say out. And I'm going to say set out to be the result of this guy. You did some filtering and some analysis, and now I said out. And now out is now Jeff and that. Okay, so now let's see. And now, the catch is you can only output text. You can't output lists. So how would you take out into making it a list? How would you put this back into text? Well, watch this. What if I joined with, remember I told you how to join these numbers with commas? So what if I took this guy, this is all the beauty of this idle function stuff, combine it, elements of this, I'm going to combine these guys with my same join guy, but my join is going to have, my join is going to have 3 spots. Join, here's blank, that's a spot, that's a blank. This middle guy is going to be the character. We have a Unicode set here. Let me show you this. Unicode of, I think it's 10 is line feed. So I think it's Unicode sorry, Unicode big as letters, so Unicode of 10 as letter. This is the line feed. Really, this should be, I should be able to just make that. So if I join this, let me try this. Ready? Okay, watch. Let me try joining this list. Combine. I'll test this here. Duplicate this. I'm getting a little bit big. My text is really big. Usually, you have a lot more room than this. So I'm going to show you this HTTP block in a second. So I combine, throw this away. Here's my list. Okay, and here's my join guy to test it. Bink. How does it work? Ready? Oh, look. Carriage returns at the end of every one. So 10 is a carriage return. So if I take this and put this in here, now, watch this. There's my Jeff and Jan back as text, not as list anymore, but I kind of now combined with this is the way you went from text back to, sorry, list to text. If I set out to this, watch this, set out to that, Bink, out is now, notice this is out went from being a list of elements to being text. It's a little different color. If I right-click, I have export, and this is the text that I concluded. So the way to get data in and out is import and export on the stage. That's how you do this. I can click import to get data into a text file or data out of a text file. You can do that with lists. Lists only allow you to import into them. Let me finally show you this HTTP block. If you had a service out there in the world, you could actually pull in the raw data from that service. This is how we connect with the Finch robot. If you've never seen the Finch robot, it is Finch robot. See if I can get that for you really quickly. Here's the Finch robot, and they work. It's a delightful little guy, and it works seamlessly with Snap. The thing is, you have to run a mini Python server. They give you the software to do this. You click a button that says Start Server, and what the server does is it listens to requests that this thing sends on a certain port. So it works by means of this block being the input-output. That is to say, this is obviously a way I could go to the web and grab and slurp some data, but I also is a way if I had some arguments, like question mark, foo equals 7, how does the thing, plus bar equals 6 or something, and this is the URL way of doing this, I could be passing something to a website that was expecting this input. The foo would be set to foo would be set to 7, bar would be 6. So this is a nice block to be able to do input or output of things. So you can have a service in the background. I actually have a game. It's a really fun exercise. I had a back-end server that has the answers of tic-tac-toe. So you give it a position in tic-tac-toe, it'll give you the answer, like what to move, what to do, or whether it's a win, lose, or tie. And I had a student who used that to make a tic-tac-toe project to play perfectly. And he used this block to send, it was sending the command was, here's the tic-tac-toe position, and the return value that's here, was the value win, lose, or tie, and he was using that in his visualization. So I hope that answers the question in terms of getting that stuff in and out, but it's HTTP block, and it's the import and export from the list.
Okay, great. Thanks, Dan. Well, we have just a way to wrap up. There's a lot of teachers who are very new to computer science, so can you give them just a few encouraging words in closing about how computer science principles is different, some of your experiences, and just ways to encourage them about adopting CS principles for the first time?
Sure. So we've been fortunate to work with NSF and to get have a family of people taking BJC. But in general, this is true for all the CS Principles courses. So this summer I may have worked with my 200th teacher, which is exciting. Long story short, I've worked with teachers of every range. I was a programmer for 10 years, and I came back into teaching, so that person doesn't need to be taught computer science. To somebody coming from math who wants to get into computer science but doesn't. And I think I've never seen a course more accessible to that group of teachers than AP Principles, in which, of the 7 big ideas, only one is programming. And you can, I work on the development committee, so I'm kind of, I see what's behind the wall as the people making the sausage, making the actual exam, making the assessment items, and I see that. And what I'm seeing is that remember that there's a lot of variation in the flavors of CS Principles. There's mobile CSP that Ralph Relli has done, this version that Jeff has done, which is similar in some way because of the Snap connection. There's our BJC. There's lots of different, there's Beth Simon's outstanding work at UCSD. Lots of wonderful educators that are putting together really wonderful courses, and they're all great in their different ways. They each have, it's like looking at your 4 children. I love you all the same, right? They all have their good things and the things that aren't so good. So everybody has mostly great stuff, and I think it's just dynamite. And in fact, there is some initiative from code.org to put us all together and to say, like, let's all share from each other even more as code.org is putting together their own version. So they're all going to be hopefully learning from each other as we do this. It's an exciting time. It really is an exciting time. So the point is, because there's so much variation in the different courses that we all want, you know, the 1,000 flowers to bloom. We all want those to succeed as long as they adhere to the framework. The framework's like a skeleton that you hang different meat on. It's like a tree that comes from for holidays, and you hang different things, and different people hang different things on that tree. So you can get to the big ideas, the knowledge items, the computational thinking practices in many different ways. It's not heavy-handed in terms of telling us what to do. Many of us are offering, here's what we do, and please choose it. When people who take our BJC, we never say you have to do every line. If people say, I want to adapt this and make it my own thing, that's wonderful. So all of us are mostly making our stuff available, Creative Commons, to share, and because of that, the people like me who are writing the exam can't make a question that is only about mobile and App Inventor. It can't be about Snap. It can't be about Python. It has to be general enough for everything. And so it means that the programming questions, when they come up, are about as difficult as you find when you do the hour of code. You know, it's the little algorithms, the little stuff, and it's not a ton of code. It's not the AP. So the APA is a scary new course to teach if you're a non-programmer. But boy, APCS Principles is really accessible because so much of what you're doing is sharing those big ideas. It's talking about impact. It's having dialogues with your students. It's having them do creative things like CS Unplugged activities where your body is part of the computer, and maybe it's a linked list, or you're learning about encoding, and you're reading about Blown to Bits, which is the book that we share and other people are using. You're reading about websites that have current events. All these things are important, and all these things are part of the things that are assessed at the end of the day. So the reality is, you don't have to be that strong a programmer to actually be a great APCS Principles instructor. The beauty is we have each other. So when a student asks you a question that you don't know, turn to all of us and ask the question. We have a family of about 200, as I mentioned, BJC teachers, and we have a running piazza. So at any stage, anybody asks a question, how do you do this in Snap? Could you do that? The student asked me this, I didn't have an answer. We kind of are supporting ourselves in that way. So in terms of kind of a, go get them kind of advice, make sure you turn to each other as you launch the class. Try to get as much up as you can in terms of the actual programming so you're feeling more comfortable. The more, you learn by doing. So as much as you can when you're idle, I tell my students, rather than Facebooking when you're idle, code. Coding is good for the soul. So as much as you can, start to explore all the things. So hopefully by the end of the summer, you've explored every single element to the Snap interface, and nothing, you've made a project that has everything in there. So what's that sensing box? Ooh, that's kind of cool. Oh, I see. What's when two sprites are next to each other. A lot of this inherits from scratch, and there are a lot of resources from scratch that you can also make use of to help you learn this stuff. So I would say that don't be scared. I would say that you're going to have a great time. Make use of the community to have your questions. Do check out Blown to Bits, as I mentioned. I'm not sure, Jeff, is that part of your official thing?
Yeah, they're already doing some reading. Yeah.
It's an outstanding book, and really it so grounds how stuff really works, how the internet works. That's one of the big ideas, is how the internet works, and I think that there's an appendix A, talks about that. That's such an outstanding resource for you. So in general, try to get as much programming experience as you can between now and then, but you'll do fine. Even if you're not the best programmer on the block, you're going to be fine as an instructor because A, Snap is so accessible, and because you have the support network of Jeff and others like myself to help you with that.
Okay, well thanks a lot, Dan. We really appreciate you taking the time out and sharing your thoughts on Snap with us, and we're going to have a lot of Snap programmers by the end of next week. So
that's wonderful. That's wonderful.
We appreciate your time, and there's some questions maybe we can pass off to you if you want to, so that we didn't get to, that if you could respond back, we can make sure we get the answers out on our Piazza board. So.
Sure, wonderful. Thank Thanks, everybody. Hey, so happy to do this. I didn't get to meet you all, but virtually I'm saying hello to the world, so it's great to be here. Thanks so much, Jeff, for doing this.
All right. Thank you all. We'll see you next week. Next Friday, we'll have with us Michelle Roberts, who's prepared a bunch of she's prepared about 15 to 19 videos on data. So she's going to go in data in a lot of detail. So this is what we've heard is a real need with CS principals. So she has some really fun activities. It's like a mystery kind of activity throughout the class, and we'll be sharing those. And Michelle will be on air with us next Friday. So thanks again to Dan, and we'll see you on Piazza and live and Hangouts, and see you next Friday. Thank you.
Hi, everybody.